The construction of beauty, geometric patterns in Islamic art. There are three types of decorative constructions in Islamic art: calligraphy, vegetal patterns, and geometric patterns. There is a geometric pattern that we will be discussing titled the girih. Geometric patterns took off after Al-Khwarizmi completed his first writings on geometry in the 9th century, along with his findings in algebra. Islamic artists refined these patterns into more complex designs, resulting in the girih tile, which was a popular addendum to Islamic architecture that was developed around 1200 CE. In Islam, it is forbidden to idol worship except the worship of Allah. Mosques were constructed with this in mind, using geometric patterns as decoration rather than characters or persons which adorn most religious buildings. To add to this, Islamic scientists drew from Roman, Greek, and Sasanian influence as they had constructed patterns before, and Islamic artists took key elements from their art to mold it into two values important to Islamic society: unity and order. The incorporation of geometry grew with the expansion of Islamic math and science. Islamic art developed its own distinct style during the rise of sciences and maths, which is also when girihs were more fully developed and became popular. Girih translates to knot in Persian. From this came girih tiles, which are 5 tiles of girih combined edge to edge to form a cohesive pattern. It is by far the most identifiable pattern in Islamic art and is seen in nearly every piece from the medieval times, from mosques and other architecture to more mundane things such as bowls and cupolas.
Though there are many types of girih designs, girih are generally based on repeating star-shaped patterns, surrounded by geometric figures. One of the simplest designs for a girih consists of 2 squares, one set at a 45-degree angle to the other, to create an 8-pointed star. By continuing the 2 grids on which these squares lie, the pattern can continue on endlessly. Craftsmen designed girih patterns using Euclidean tools, a straight edge and compass. With these tools, they could connect 2 points with straight lines, extend line segments, make curves with set radii around a certain point, bisect angles, and construct basic regular polygons, as well as other geometric functions. Originally, Islamic mathematicians would use tools in the direct strapwork method by constructing a geometric pattern within a unit cell, which they then repeated to create a periodic pattern. However, the unit cell method was restrictive in that it only allowed for 2-fold, 3-fold, 4-fold, and 6-fold rotational symmetries, meaning the number of times a figure repeats itself within a 360-degree rotation. In 12,000 CE, the creation of 5 decorated girih tiles for constructing geometric line patterns opened up new possibilities. Here is one example of a girih construction from the shrine of Khwaja Abdullah Ansari at Gazarga in Herat, Afghanistan. This pattern can be constructed using the 2 methods: direct strapwork within a rectangular unit cell, or using girih tiles. First, a circle is inscribed and divided evenly by 10. Then, every 3rd point on the circle is connected by a line segment to create a decagonal star. The points of this star are used to create 2 semicircles. The unit rectangle should have the same height as these semicircles and a width equal to the diameter of the central circle. The craftsman would then eliminate the central decagon and extend the line segments while maintaining the 2-fold rotational symmetry of the unit cell. This completed cell can be repeated indefinitely. However, the overall pattern can also be broken down and constructed using 3 distinct girih tiles. Here, a decagon with a decagonal star, a hexagon with a bat-like design, and a bowtie shape with 2 quadrilaterals. The decorating lines meet at the midpoint of each side of the polygons at angles that are multiples of 36 degrees, so that the lines meet at the borders between tiles without changing direction. With a complete set of 5 girih tiles, the possibilities of construction are endless, and reach far beyond the restrictions of direct construction using a unit cell.
Detailed patterns such as the girahs are incredibly important to the Islamic community and culture. Art is the mirror of a culture and its worldview, and the detailed artistic patterns used by the medieval Islamic artists show the prevalence of their faith and its key values. The use of mathematics to make the art was novel and is still not commonly used today. Islamic art is representative of spiritual objects, and instead of replicating something, Muslim artists work to convey what their muses are representing, whether it be the infiniteness of Allah, the beautiful symmetry of nature, or the complexity of the universe and intricate patterns. An example of this would be the use of geometry. It is thought to reflect the language of the universe and help the believer to reflect on life and the greatness of creation. Some aspects, as seen in the girih, are the complex repetitive patterns which appear unending, similar to how Allah is infinite, and the smallness of these patterns show how even in the small you can find the infinite. Into everyday Islamic life, decorating mosques, but also covering more mundane objects such as bowls, cups, and vases. Many important items, such as the Persian rugs, are used in Western culture with little thoughts about the origins of this art. Persian rugs utilize the geometric patterns to make shapes. This is an example of how the use of geometric patterns were integrated into everyday art. In conclusion, Islamic art is a major part of the overall culture and shows how core beliefs, such as an infinite God, a love for symmetry, and representing the spirituality of something, are all predominant in the Islamic culture and faith. Thank you for watching our presentation on construction and cultural significance of the girih, the history,